So you guys see my screen?
Yes.
All right.
Yes.
So the first thing I'm going to do, Alex, is I'm just going to show you real quickly how to make a data sheet. Okay. Not going to explain a whole lot of this. I just want you to get an idea of the flow and what a data sheet looks like and where they come from. And then I'm going to go into detail on all the elements of the data sheet and all that and explain it. But first, just to give you an idea of the flow of creating a data sheet. So what I did was I have essentially a blank data sheet, but I just, in the interest of time, I went in and filled out some of this boilerplate stuff, okay? The model, manufacturer, description, where the specifications came from, and the calibration procedure information. As Rob showed you, you can link these to a procedure in CMS, in which case if you have like documents like the actual cal procedure in a Word document or the manufacturer's manual, you can put those in there and you can view the technician can view those during the calibration. All right, so I won't spend a lot of time on that. This is pretty obvious stuff, right? Our boilerplate. But what I want to do is we're going to go and actually create the test points now. We can create test points in different ways. If it's something, you can have test points that are nothing more than a label, right? It's not actual data. It's not really a data point. It's just a label. You can also have data test points like pass, fail, that kind of thing that are non-quantitative. They're just essentially a go, no-go test point, and you'll create those manually by entering values. But the most of your test points are going to be quantitative test points. All right, and this example is going to be a pressure gauge, so all of our test points are going to be quantitative. And we build those with the test point builder. And the reason we do that is we want the specifications to be embedded in here for reasons that I'll show you as we go along. So for now, because this is a pressure gauge, I'm just going to tell we're going to do multiple test points at once. Okay, so, and this is a 250 PSI. So we're going to do 50, 100, 150, 200, 250, back down 200, 150, 150. All right, and our units of measure are going to be PSIG. Now, if you use it a lot, basically you'll know your units of measure. You can type them, but if you don't, you can come in here. Actually, I wanted the other one, just a simple lookup. Now, what's important about units of measure is it's important that you get it right because this is about the only thing in the system that's case sensitive. Of course, the difference, for instance, between millivolts and megavolts, right? Units of measure have to be case sensitive. So the system actually has a real-time units of measure conversion system. So if your standard and your unit under test are in different units of measure, that's not a problem. As long as there's a they share a common conversion unit, then MPS can convert from one unit to the other. For instance, all of the length units, share meter as the conversion unit. All right. So there's our PSIG, our number of decimal places. We're going to have 2 decimal places. And again, I'm just kind of doing this quickly to give you the feel of it. And we can indicate what the specs are. So this is going to be 1% of full scale. And we could use any combination of these things, okay, including our logarithmic specs for dB or custom calculators. You can do equations. So if you did have something like that, add 0.1% for every volt above 500 or something, you would do that with an equation. But in this case, we're just going to have a simple 1% of full scale. So I need to tell it my full scale is 250, and then my 1%. And of course, you could either do percent or ppm. That's selectable, but this is going to be percent. And then I'm going to tell it to create my test points. So let's insert our test points. And in here, now this function tested, this is just a label.
Okay.
So this is going to be pressure tests. And then what I wanted to do for the subsequent fields, I can either have it put in, I like to put in the pipe character, or you can have it repeat pressure tests for each one, or just leave it blank. All right, and then this test number, step number, this would be like from your actual calibration procedure. Okay, this is, again, these 2 fields are utterly meaningless to MPS. They don't mean anything. So I'm just going to put 4.2.1, and that's because my calibration procedure that's step 4.2.1 of the cal procedure. All right, and then in here for my measured value, Where's the measured value going to come from? Direct entry one value. That means that essentially we're going to enter a pressure value, or with automation scripting, if we automate it, there's going to be one value. Your other options here are mean of samples. So if we were setting up a torque wrench, we would choose mean of samples and we would set it up for 3 samples, right? Because we're going to do 3 clicks and the average of the 3 clicks is the measured value. Now, by the way, when you do that, MPS will automatically take the standard deviation of the samples and add that to the measurement uncertainty budget
Oh,
item
wow.
yeah. And then calculated prompt. So if we were doing something like a current, right, where the technicians, you're going to use something they have to calculate, like they're going to have a resistance value and a voltage value, and then we needed to calculate the current from that, we could do that. So it will prompt them to actually enter like the resistance and the voltage, and then it would calculate the current and then make that be the measured value.
Hmm.
But for our pressure gauge, it's just going to be direct entry one value. Now, for our reference value, the default is that for something low end like this, we're going to assume that the nominal value is the reference value. So we're going to set our pressure calibrator to output, 250 psi, and that's going to be the reference value. If we were doing something like temperature, for instance, right, where that's
Right.
never actually the case, you set the bath to 250 degrees C, and really it's 249.95. In that case, you're going to do direct entry. And when we do this, before the technician can enter a measured value, they'll have to enter a reference value. And when they enter the reference value, MPS will automatically recompute everything around the reference value,
Hmm.
including the calibration tolerance for the test point, the high and low tolerance. It'll recalculate the standards accuracies, update the uncertainty budget, and everything based on the reference value. And as Rob was starting to explain to you earlier, the as found and as left are completely independent in MOX. So you can have different reference values for as found and as left on the same
So,
test point.
so different standards, different uncertainties.
Exactly. So,
Yeah.
right, exactly. You can use different standards. And even in the case of temperature, if you did have to go back and take as left data, it's not going to be the same reference value, right? You'll set the bath to 250 again, but it's going to be somewhere else.
Right.
Okay, so again, in this case, low end pressure gauge, we're just going to use nominal value. Now, if we were doing high end pressure, right, that would be a different matter, right? We'd have to get the true pressure, and that would be our reference value. But in this case, then we're going to assume the nominal is that. We hit OK, and here are our test points all created for us. And then it embeds in here a human readable version of the specifications. All right. But really what happens is it's actually stored in all these test points, the actual specifications. All right. And this will become important because, as I was mentioning, when we do like that reference value thing, it has to recalculate the tolerance around that. So it needs the actual specifications to be able to do that, right? Because it could be nonlinear.
Right.
All right. All right. So now you'll notice I've got no TARs, TERS, EMUs, PFAs, PFRs, none of that stuff. So what I need to do is I need to give it a basis for that. So that's going to be our uncertainty budget. And I could do this one of two ways. I could just go in and create uncertainty budgets manually. Okay. Or I can have MPS do it automatically. Now for that, if we go to standards here, what we're going to have is one standard, and it's going to be a pressure calibrator. All right. Now, where is that pressure calibrator going to come from? Well, in MOX, we have a thing called MetSpec. And MetSpec is a digital specification system. Okay, so you can actually store the specifications for instruments in electronic form in these MetSpec files. And these, of course, get saved in the database. In this case, for a pressure calibrator, it's relatively simple. If we go to our PSIG units, you can see these are the different modules that are in this pressure calibrator. And then so for our 0 to 45 PSIG, this is the parametric limits. This is the accuracy for 1-year accuracy. And this one actually uses a equation. So just give you a quick look at that. So here's the actual equation for that to determine that. And again, I'm just speeding through this right now. We're going to come back and look at these elements in detail, but I just want you to sort of get the flow of how a data sheet is created. All right.
Okay.
So So now that we have that, and the main usage for MetSpec really for most people are actually for using it with calibration standards. So you have the specs for the standards. Or in some cases, if you want to set it up with using uncertainties, you can do that. All right, so let's go ahead now and tell it to add an instrument to this. And we're going to import a MetSpec instrument for that. And it's going to be our CPC. And incidentally, this catalog that we're using, this is also common for data sheets. If we were building a data sheet as we're doing now, and basically, if we don't have the rights to approve it, or we're going to continue working on it tomorrow or something, we can save it as a file. And then it's the same thing for MetSpec spec sheets. If you create a spec sheet, you can save them as a file while you're working on them. And then you have to have the necessary permissions to be able to approve these into the database for actual usage. And so what you do is you'd save them to a file. And then when you're done, if you don't have the rights to approve them, you can just email the file to somebody that does, and they can go in and do their review and all that stuff. And if they approve it, then they can approve it into the database and it'll be ready for use. In the case of spec sheets, they'll be ready to be used with data sheets. And in the case of data sheets templates, they'll be ready to use for calibrations once they're approved into the database. And all of that is all audit logged and revision controlled. You can have multiple revisions for both spec sheets and data sheets. So if you change it, it retains the old versions. So you have all that control. All right. So here's my calibrator. And what I'm doing here is when I'm typing, it's actually looking up in the database to find that. So it's things that start with CPC. And we could search different ways, model number, description, all that. But I know the model number starts with CPC. So there's a CPC 6050. I hit OK. And then this one just has 1 year specs. So OK. This is more common in electrical stuff. You might have 90-day specs, 1 year specs. And what you would use are the ones that how yours are calibrated. Okay, so now I've got that. So now, just to give you an idea of, well, I already showed you what the spec sheet looks like, but you can also view them here in MPS as well. But now what I need to do is for those different ranges, pressure modules will be assigned to different test points, right, based on what they are. Now, how do I do that? If I go to assign standards to the test point, I can tell it to auto assign. And what it'll do is it will use the parametric limits in there. And I'm going to tell it to do it for all test points and do the whole calibrator. Okay, so now you can see that we actually have TARs, TERS, EMUs on our RISC, PFA, and PFRs computed. And if we actually now go and look at the test points, you can see that for this 47 to 52, or this 50 PSIG test point, it chose the 0 to 235 PSIG module, right? And it's actually showing me the specs for that. And my TAR is 212 to 1. Okay. Now, that's largely what you'll use spec sheets for. This is really, really super handy for like your general purpose test equipment, right? If we were doing like a primary level calibration, then, we might actually do more with the uncertainty budget, manually, right? Which you can always do. You don't have to use MetSpec instruments. You can always just manually create budget items, and you can also do a hybrid. So you can have MPS do this stuff automatically, and then you can also go in and add other budget items if you want. Okay, but this is really the super powerful for that general purpose test equipment, right? Where you've got a ton of pressure gauges and you don't want to have to go in and manually set up a uncertainty budget for every pressure gauge you do. This saves you a huge amount of time. And
Yes.
also you could let your technicians do this because all the metrology stuff is done in the background. So they just chose the calibrator and they basically set up their test points and they can do this. And you have a lot of confidence that basically all this is being done correctly and all of that. So, okay. So now that essentially is creating a data sheet. So what I would do is while I'm working on it, if I don't have the permissions to be able to approve it into the database, then what I would do is I would go to export the template. So I'm going to save it to a file. And then let's say you, Alex, basically do have the rights to do it. I can email this to you. And you
Okay.
can basically open the file and you can come in and review it. You can just come over here and look at the specs and say, yeah, these are these are the right specs. And then you can look at what I chose for the standards, right? Say, okay, yeah, that looks good. And then there you go. And then what you would do is you would go to File, Datasheet Template, Approve Template to Database, okay? And then you basically would approve it as a new document, or if it's an existing document, you would approve it as a revision. Okay, in which case, if there's a currently active version already, that will become inactive and the new one will become active. And all that stuff will get audit logged too. Okay, so
Okay.
that's the process for creating a data sheet. Now I'm going to basically go and show you some of the technical stuff about what MPS does with all of this and how it all works. All right, so let me get that out of the way. And by the way, I have several data sheets preloaded over here just in the interest of time.
Okay.
I don't
Did you
need
have any
that thing up
questions on the
there.
data sheet stuff, Alex?
Yeah, no, it was actually very straightforward and very simple. I'm assuming, getting your standards and uncertainties, might take you a little while, but once it's all in there, just being able to pull it in, that's super
Yeah,
How does
easy.
that
yeah,
how does that compare like to what you're used to using for like other softwares? You know, the naming softwares, but I mean, does this look any different or is it look more user friendly?
I could tell you everything looks very clean here, organized. I really like the visuals that, you give with the tolerancing. It it's all I could say is it's very neat and organized, and you can actually see all your data in one page.
Have you
there you go.
found it to be just the same, easier, harder to build data sheets in other systems from what you just saw?
Yes, this made it very simple. I would say this is probably one of the easiest I've ever seen being created so quickly. So
And plus the uncertainties too, right? I mean, just you can create a data sheet. I know some of the softwares they create data sheets, but they don't really handle the uncertainties. They just handle the data points and tolerancing. And then you're usually manually typing in the uncertainty, or you got to do some kind of scripting for it to know how to do the uncertainties, right?
correct, or having it organized to where it's pulling in the ranges. I've seen some programs just have issues with recognizing that this is the part of the uncertainty budget, or this is the spec for this portion of this part of the calibration. So
Yeah, it knowing
yeah,
what module, you have that CPC, right? And it's multiple modules. It knows what module to pull from, right? So it's going to be able, it's pretty smart and intelligent that way. I agree.
yeah.
All right, so what I'm going to do now is I'm going to show you in a little bit more detail what I did again in the order of time. I have this is a 5.5 digit data sheet, which is what's actually set up behind me over there on the
Mm.
5522 calibrator. And on the top is that Regal 5.5 digit DMM. Okay. But I have here already a set of as found and as left data collected for this in the interest of time. I am going to show you taking a couple of data points because I want you to get a feel for what automation looks like executing in MOX. Now, this is an important thing about automation in MOX. It's completely optional. What you saw me do with the pressure gauge, that's the way you start with any calibration you do, whether it's a pressure gauge, a micrometer, or a RF microwave measuring receiver. Okay, that's going to end up being automated. Doesn't matter. You start off by doing the metrology first. So you create all the test points, set up your metrology, and then you can add automation scripting to that anytime you want. So if you get in like a brand new make model DMM and like one or two of them, right? So you can create a data sheet, you can approve the data sheet, and you can do calibrations. If you get to the point where, hey, we're getting a lot of these things in now, let's go ahead and automate it. At that point, now you can add automation scripting to it. And then you would approve that as a revision of that data sheet. Same data sheet, just now it also has automation scripting.
So
Okay.
yeah, Alex, like when we were in the labs, right? And you're dealing with something like that, it doesn't work that way, right? Your formatting gets all messed up, right? So now you maintain the format of your cert, right? You don't got to do any reformatting. It'll always be the right format.
Well, yes,
Right.
and even more importantly, basically all of your measurement history is still intact. It's still the same test points, the same test point identifiers. So I'm going to show you in a little bit with the analytics. When you go and look at like all of your measurement history for these test points, it will still be the same, whether you did it automated, manual, it doesn't matter.
Yeah, because you go over to another program to do automation that's not part of your metrology software, they might determine different test points, right? Or may whatever it
Right.
might be. So you already have the same data sheet that's been used for years, and you said you have that history, and the customer doesn't see new test points, and you just
It
now it's automated.
And even if they were the same test points, what's different about this is this has globally unique identifiers for every test point. So these have a unique identifier for the test points. And so when you capture the data, it actually associates those identifiers with it. That's how we can find unambiguously the
Mm,
calibration history for this test point, because those measurements
Wow.
actually contain the
yeah.
reference ID for this test point. Okay, so now I'm just going to, before I get into anything else, I'm just going to give you a quick example of what automation looks like. So we'll just let it redo a few test points here. And I've got the 5522 calibrator selected. This is the case where you can see for this meter calibrator, instead of adding one met spec instrument for the calibrator, we actually added four. So the technician at the time of calibration can pick any one of these that they're going to do the calibration with. And then depending on which one of these picks, it will completely change the uncertainty budget and everything. But you'll see that in a little bit. But first, again, I'm just going to run this. And again, as Rob showed you with his Fluke 77, you can see here, these are places where they're teal. And by the way, all these ones above are all zero tests. So I'm just skipping those for our,
Okay.
because that just has you connect a 4-wire short and does all the zeros on all the functions. Because when they're automated, you want to minimize the number of connection changes you have to do and all that. Okay, so let's just go ahead and run this. And then it comes up, you can have instructions
Oh, wow.
in here as we do. And for instructions, we use RTF, which means that when you edit these instructions, MPS, MOX has a built-in RTF editor, but it's fairly basic. You can get the job done, but I usually like to do these in Word, and then I just paste them in. Right, so you can actually take excerpts from your existing calibration procedure in Word and just paste them in here too. All right, and then you
Wow.
can include images. So as I'm doing here, this is showing me how to connect the equipment. And I do currently have the calibrator connected in this configuration. So we're going to go ahead and hit continue. And I don't know if I'm in the way because I can't see me now. So let me just move
Oh,
aside here.
okay.
I don't, it might be too
Yeah.
small to really see anything happening over there anyhow, but it's, waiting for stabilization, which is, most of what's going to happen. And then so we've done one point, now we're doing another. You won't see much here because, we already have data. So it's just repeating the measurements. You can see it changed a little bit. All right, so I'm going to stop this. I just wanted to give you the sense of it. So that's basically what automation looks like executing. And we're going to show you other kinds of examples in MOX because with MOX, automation isn't just about this. It isn't just about automated test equipment. We have we do a lot of automation that's just process automation, right? Where, for instance, you may have a data sheet that's set up as a template for pressure. You may have like a 3-point and a 5-point data sheet, and we don't know in advance what points the customer's going to want to do their thermometers at, right? So
Right.
the automation scripting will prompt the user to enter the 3 points that they're going to do, and MPS will use automation scripting to completely reconfigure the test points for around those 3 points. Okay. Also, I'm going to show you other examples where we use automation scripting to actually import data from other systems. I'll just skip that for now, and I'll show you that when we get to it. I'll explain that more about that when we get to it. So now what I want you to see is we have calibration data in here for this. So now I'm going to come here and look at this information about the actual measurements that were made. This is another big thing about MPS. Okay, for my 5520, you know what? 5520 is too close. All right, what I'm going to do is I'm actually just going to pick for this test point. I'm going to go back and repeat one as left measurement, and I'm going to choose the 5500 calibrator. Okay. Now, The only way, by the way, once you make a measurement, the only way any information from that measurement will be changed is by repeating the measurement. So when I repeat this measurement now, so 199.997. All right, so now you can see what happened was if I click back on this test point, you can see it's guard banded. All right, if you look up here at my as found and my as left measurement for the test point, and incidentally, in the MOX software, everything in the system is driven around the currently selected test point. So in the user interface, whenever you change test points, you're going to see all the information in here is everything around it. I always say the true document in MOX are test points, not data sheets. Data sheets is just a collection of test points, but everything in the system is centered around, the test points and what constructs them and their history. Okay, so now when I look at this test point here, you can see that for my as found, I used the Fluke 5522 calibrator, and that gave me a standards accuracy of 5 microvolts. And again, these were met spec instruments, just like I showed you with the pressure calibrator, right? Of course,
Right.
there are a lot more complex spec sheets because they have a lot more functions and ranges and all that. But anyhow, here's the actual accuracy is 5 microvolts. And then this is showing me that I used the 330 millivolt range, and these are the actual specs for that range of the calibrator. And then when I look at my as left data, I used the Fluke 5500 calibrator, and that was 15 microvolts. Okay, so when I look at my results up here, you'll see that my tolerance for my as found is just using the design tolerance because my TUR is 9.7 to 1. And my PFA is well under my target PFA of 0.8%. Okay. But when I took my as left data using that 5500, my TUR dropped down to 2.5 to 1, and my PFA is above my target PFA of 0.8%. Okay. Now, what's important about this is that MPS then automatically guard banded, and guard banding is optional in MPS. So if you don't want any guard banding, you can basically turn off guard banding. And if you do want guard banding, MPS supports 3 methods for guard banding. It supports the old RP10. If you're familiar with Mudcats, for instance, it used the RP10, which is just a fixed percentage of the EMU will be the guard band amount. Or you can do the Z540.3, and we use the RP18 iterative statistical method to actually determine the guard band multiplier. So what it will do is it will keep adjusting the guard band multiplier till it finds the guard band multiplier that just returns it to the target PFA. So you'll get just enough guard banding to get you back to your target PFA. So you can see that here, right? With the design tolerance, our probability of false accept was 1.08%, and then with the guard banding, 0.8%, back to our 0.8%. And the third method is the RSS method, and that's used a lot by the DOE folks. Okay, so that's that. Now, everything that you see in here is actually saved with every measurement. There's a completely independent uncertainty budget saved with the as found and as left measurement. Okay, because if we were, for instance, doing sampling, and if we had the test point set up for sampling, then a sampling section would appear to enter samples. Okay, and then it would automatically make another budget entry for the standard deviation of the samples for the measurement. Okay, and then for our as left, you can see again everything that I already showed you, right? Where you 15 microvolts, and then in our uncertainty budget for our as found, it's got the Fluke 5522 calibrator. In our as left, it's the 5500 calibrator, right? 7.5 K equals 1 microvolts for the 5500, and 1.9 at K equals 1 for the 5522. All right, so it's completely dynamic. And if we were doing reference values, if you remember when we did that pressure gauge and we were creating the test points, I told you another option that you had was to tell it about how it's going to get the reference value.
Yes.
And the default is that the nominal will be the reference value. And you can see that here, right? For just a lot of your general calibrations are that way. But if we were doing pressure and we told it we want reference values, than before. And if you were doing it manually, before you could enter a measured value, you would have to enter a reference value. And when you enter that reference value, MPS will recalculate everything, your tolerances around the reference value instead of the nominal value. It will basically recalculate the standards accuracy around the reference value, and then that in turn basically feeds into the uncertainty budget around the reference value, so on and so forth. And that, of course, your risk and all that stuff is recomputed. And just to give you a functional example of that real quick, what I'm doing is I have on my other screen here, I've got a bunch of copies of MPS loaded up with stuff to save time. So I'm just going to run this example real quick. This is just, I use this as a stress test, but this actually has just a bunch of standards in here. And what we're going to do is it's just going to run through, and I'm going to tell it to iterate through measured values. And what it's going to do is it's just going to go through and make little changes to the reference value here, okay? And as it's doing it, you can see my tolerance is being recalculated.
Wow.
And this is automation scripting that's doing this in the background, MPS automation scripting. And you can see my PFA is changing. And then eventually we'll get to a point where our TUR and our PFA is going to get above our 0.8%, and then it's going to automatically start guard banding. So you can see we're getting, there it is, right? So now it automatically started guard banding because it basically no longer met our PFA requirement. All right,
Alex,
so
have you seen anything like this before?
I have never seen anything like this before.
know,
But it's
but,
actually
you know-
calculating every so every little change that happens during the calibration, I mean, it's being it's accounted for when it's calculating the uncertainty. It's
Yeah, on
not
the spot.
just set. Yeah.
But wait, there's more. So what another thing that you can do too is the uncertainty budget. A lot of times when you're doing a calibration, you may not know the uncertainties until you're actually doing the calibration, right? So you may
Right.
be using something like thermal converters, or something where you've got a reference, right? Or
Yes.
SPRTs, that kind of thing, and you're going to use information from their actual calibrations. So you have an MPS, you have a global text files where you can actually set up for storing those references like coefficients or whatever for instruments. And then at the time of calibration, you can have MPS, with the automation scripting, access those, and there are automation scripting commands to completely manipulate the uncertainty budget at the time of calibration, right? So you can have it clear the budget items, and you can have it, calculate and add new budget items while the calibration is underway. All right, so what I did here is I just wanted to give you an idea of the big picture where all of these bits and pieces all come together. Okay, and this is it when you're doing the calibration. And everything that you see here is actually saved with the calibration. So if you basically have an audit and you basically pull up this calibration, all of this information, you go to any test point, right? And as I go down to different test points, you can see that information is being displayed. So you can show the auditor exactly what's going on here.
Wow.
All right. All right, so now what I'm going to do is I just want to show you another couple quick examples here. I tend to do a lot of electrical stuff in there because of my example with the guard banding and that. But this is just another example with a micrometer. Okay, where again I have as found and as left data already taken. And so you can see it's not just about electrical. Here we're doing a flatness test, anvil parallelism, and then our length and linearity tests, right? And basically if we look at our standards, so if we look at basically our planned standards, so here we've got, we're going to be using an optical flat for that one, an optical flat for that one, an optical flat for that one, and then we're going to use gauge blocks for these. All right, and these, what we have for this is we have this set up for this lower end M&TE like that. We're actually just using the class tables for the gauge blocks, right? We don't need to use like individual values for individual blocks for doing like a micrometer. All right. Yeah, so let's go ahead, and I just wanted to give you a view of that real quick, just so you know, this is like intended for all types of M&TE. So now what I want to do is I'm going to go back to datasheet design, but I just want to show you some stuff with advanced uncertainties.
Alex, how do you know, when you're now as we coming in here into the advanced uncertainty section, I'd like to hear a little bit really before he gets going into there, like just what has been your experience with dealing with calibrations, writing data sheets and trying to get uncertainties, wrangled up right in the lab to where, they're for sure they're correct. They're not reporting better than your SOA. I mean, you're using different software, right, to generate that stuff. Can you kind of go over that a little bit compared to what you're seeing here?
Yeah, so a lot of the issues that I've seen is really just tying all the test points to, the particular part of the budget, or when people are creating data sheets, you're wasting time because if you didn't do it a certain way, you miss out on being able to tie that portion to that particular part of the budget. What I'm seeing here is just very organized, it's very neat, it's clean, and everything is just pulling in exactly from where it should come from, So I would be more confident in doing it this way, knowing that my uncertainties are going to be correct and in other ways that I've seen it done. So
Well, I think one of the advantages here, Alex, is that, you know, because the system is here and you can validate the system and all of that yourself if you want. But once you're confident that the system is doing what it's supposed to do, that lets you kind of push some of this work down. Most people that use MOX, it's actually the technicians that create the data sheets and this stuff. And you don't have to understand everything about the uncertainty budgets and all of that stuff to do it because it's going to do that for you. I'm talking about like for your general purpose test equipment
I
stuff, right? I'm not talking primary, secondary level calibration, but
right.
general purpose test equipment where your volume is, right? So you can have your technicians, if they get a new new handheld digital multimeter, you don't need a metrology engineer to create a data sheet for it, right?
Right. And that it's super simple and just that once you
And you
actually
still have the
use it
approval
and pull in the
process.
uncertainties.
Right. So
Yeah.
this is what happens a lot. So the technicians will create the data sheet and then they'll send it to the metrology engineer or whoever the person is or persons that are authorized to approve them for that lab. And typically people will do it like maybe the senior techs in the lab can approve them or a metrology engineer and they'll actually review them and say, okay, yeah, this all looks right. I'm going to go ahead and approve it. And then it can be used for calibrations. And incidentally, that is an option, whether or not they have to be approved first. And most people do, through under control, of course. But strictly speaking, if you didn't want to have them have to be approved, you have that option in the master configurations.
And I also like this system too because what it's doing is it's showing you like in here, right? In red, you see 3.7 to 1, 1.6 to 1. It's showing you, in my experience on other softwares, the technician had no clue he was 1.2 to 1, or even
Right.
upside down, right? So they're just taking data. But here, as they're going through it, they're getting highlights and saying, hey, wait a second. You might want to pay attention to what you're doing here.
Right.
And then it's teaching your technicians about test uncertainty ratios and test accuracy ratios in that way. Where the other software, just by using this software, they're going to start to learn that there's something they need to be paying attention to. And I've run into
Right.
many years in my career where they're just not even aware of it because the system's not designed to make sure they're aware of it.
Right. No,
And you're
absolutely. I
relying on your
mean,
metrologist to tell you.
yeah, having that visual right there, being able to see your TURs, a lot of the time some techs don't know, hey, I need to use a different current meter for this or something that's ranged down a little bit more.
Yeah.
And they may
You
be
see it
doing
right there.
cows forever. So
And
Yep.
that's a good point, and I'm glad you pointed out, Rob, about this because that's usually one of the things I talk about in the demos is the 5500 I only have in here for demonstration purposes because I specifically want a standard that's going to cause guard banding and stuff. But if I look at this, I have essentially the 5700 that's 6 to 1. I've got the 5520 and the 5522 that are at least 2 point something to 1. and I've got this 5500 that's 1.6 to 1.
Wow.
Okay, if I have other options, right, I might look at
Yep.
this and say, you know what, I don't need to do this with a 5500, right? So then I can basically just come in here and I can go to my standards and I could say 5500, bye-bye, right? And now it's gone. So what's neat about that, and when you do auto assign standards, just like I was showing you when you auto assign with the simple pressure example, you can do that with these too, right? You can tell it to auto assign all the calibrators and it'll assign ranges. But it makes it easy to do. And if you have one calibrator that you're not sure of, well, maybe a 5500 may be good enough. Let's find out. Add the 5500, auto assign it, and take a look. If you get a bunch of red, nope, not going to work.
Kind of reminds me
Wow.
of back in the day when we were doing Nalcoma stuff, right? Where like, oh, you had to use the standard to be 4 to 1, except this one's telling you right off the bat, like, hey, you're not 4 to 1 on the standard, and then it lets them see it because they're building the data sheet. It's pretty cool.
Right.
Right. And incidentally, by the way, redundant. Um,
Hmm.
so you can actually, anytime, if you want to view, like for instance, this range of this standard, you can actually click here on view and it will take you to the actual met spec instrument
Oh
for that
wow,
standard.
yeah.
And you could look at the information about that particular range of the calibrator. All right. So now let's go back to our uncertainties, our advanced uncertainties here. And I just want to point out a few things about this. So in here, and this is another data sheet that's just kind of like a little playground for me, where I just have some testing some different stuff with uncertainty budgeting. And this is kind of an example of what I was talking about with a hybrid for the uncertainty budget. You see there are gray items here and there are black items. The gray items are basically being automatically managed by MPS. Because I actually am using a 5522 MetSpec file for this, right? It put that in for me automatically. And then I added other uncertainty budgets. Now, I don't have to use MetSpec instruments at all, right? I could just manually add all my uncertainty budgets if I don't want it to do anything automatically. I can also tell it which things I want it to do automatically. But now I want to actually talk more about these manual budget items. You see these blue bars? This is actually an influence chart for the budget
Mm.
items. And this is just so you get a quick graphic representation of your largest contributors,
Yeah.
right? So in this
Repeatability.
case, repeatability is our largest contributor. Yeah. And of course you have the numbers over here to go with it. Okay, but now these ones, and you can see I just labeled them for my demo purpose, right? Manual budget item. If you want to add another budget item, you can just click on plus to add a budget item. Or if you want to edit an existing one, you can just double click on it, right? And so it brings it up. And when you create a new budget item manually, you give it a name for what it represents, right? And then you give it the error limit, and then you choose your distribution, right? So you can have like one of the common normals or custom probability. So if you get an odd probability for a normal, you can just do that and you can enter a probability. Your Rayleigh rectangular, your different rectangular standard uncertainties. This is just K1. So if you have something where you just actually want to enter the K equals 1 uncertainty as the error limit, it will just transfer it across. All right, and triangular and U-shaped. And then, so what happens is after you pick your distribution, it shows you the K factor for it.
Can I,
And
can I
then,
can I say something real quick?
sure, absolutely.
I just wanted to. I'm just gonna give a little shout out real quick since we're on this subject. One of the next podcast that we do, we're actually going to talk about, as you can see in this, it's pretty in depth, right? You can see you're doing repeatability, you got your standard contribution, resolution, all that stuff. We actually at MOX are going to make it, and it looks just like this, to where you could build your scope of accreditation utilizing this same process right in here. And that way you have a live representation of your SOA. And that's coming at the beginning, towards the end of the first quarter next year. So I just wanted to mention that. We're actually going to have a podcast going through and how to build a budget with that system at some point. But I just wanted to bring that to your attention because you're looking at all this really cool stuff, right? And you're thinking to
Yeah.
yourself, man, you pretty much could build a budget with this, right? Well, that's exactly
Yes.
what we're going to start doing. And we got some really cool things coming in the future that Kurt is working on right now.
Yeah, and then
Yeah.
you'll also be able to integrate your SOA into your data sheets, right? So basically with that, if you're basically have an uncertainty that's better than the SOA, it basically will automatically just use the SOA value. So
Wow.
that's all coming. So yeah, so and then were you done with that, Rob?
Yeah, I was. I just want to bring that out.
Okay. Yeah, no, good point. Thank you. So then you give it your, your A or B. MPS also says optional support for degrees of freedom. So if you want to use degrees of freedom, you can provide those sensitivity coefficient, and then it computes the K=1 uncertainty for you. All right, and then basically puts that in. And then now there's also a couple of other tools to help you create a budget item. So you have repeatability here. Now there are really three ways to do repeatability in MPS. One is if you have nothing, right? You want to have a repeatability item, but you don't have any data or anything. So you just want to use like one count at the measurement resolution or at the resolution for repeatability. Then you can
Right.
just choose this automatic option here, and MPS will add that to the budget for you automatically. Just it really is the same thing as measurement resolution with a different label. Okay. And then yeah, so and then also we don't have in here now, but we'll be adding in the future reproducibility. Same. All right. And the third way is, of course, if you actually really do have a repeatability study, there's a repeatability tool here in the budget item that you can click on. And when you click on this, you can actually enter your repeatability data. And if you have it in Excel, you can just like sort of copy the column and you can paste it in here, right? You don't have to retype it. It's basically, or actually from any carriage return line feed delimited list, right? So if you just have a list of values that are carriage return line feed delimited, that's basically, you can just paste them in here. All right.
Nice.
And then it will calculate the results for you. And then, come up with your K=1 uncertainty value for you. And it also, as you can see, when I brought this up, it actually saves these with the test point in the data sheet.
Oh,
Right.
wow.
So you actually have your
Yeah.
repeatability data saved right with the data sheet. Okay. And then another tool that you have is, we were talking about when you're doing the uncertainty budget, you have to provide an error limit, right? Well, if you need a little help calculating the error limit, there's the tolerance limit tool. When you use that, this is another potential use for MetSpec. So if you have like another MetSpec instrument, maybe that just has some uncertainties or something for things that you want to add in this uncertainty budget, right? But it's not necessarily added as a calibration standard with a TAR, right? Because we don't want to add a TAR to it as a calibration standard, right? It's just basically going to be added just to the uncertainty budget. And that's the case, you could use a MetSpec instrument for that and choose a range, or you can just manually provide specification data, right? So you can give it like a percent or ppm of full scale, indicated value, floor error, or logarithmics, right? So just have it build it from specs from something, and then it will calculate the error limit for you.
Wow,
All
this is
right.
like a full-on uncertainty calculator all in one place.
Right? Right? Yeah, it is. This is,
Yeah.
and that's why I get so excited. I said, I'm going to blow your mind because we've been doing this, what, now 30 years? And
Yeah,
it's just not,
absolutely.
the software is not this easy to work with like this. This is new, right? This is like,
Right,
whoa.
absolutely.
I always like to do it like the late night, infomercials. How much would you be willing to pay, for this? Would you be willing to pay $100,000? No, I'm just kidding. Um,
And
um,
but you can see that passion he's got in it, right? He knows that. I mean, I got to say, our team is extremely passionate about the software,
Abs-
especially Kurt. And he's always got it, but wait, there's more because there's just always more.
But wait, there's more.
Yeah.
well, I literally, well, just like you guys, right? You started off as a young Marines in metrology. I mean, we all grew up in this field. I mean, most of my adult life has been in metrology, and I love like working with the metrology engineers and writing different software for different disciplines. But I digress.
Yeah, it's
Um,
great.
another thing that you can have are what are called multiple test point equations. Okay, and what these are about is here we have three test points: one for length, one for width, and one for height. All right, and each one of those has its own uncertainty budget. Okay, and its own, specifications and tolerance and all of that. So they've got, their own TURs, EMUs, all that stuff. And then we have two more test points, one for area and one for volume. And if we look at the volume one, that basically is going to use the length, width, and height test points. And you can see that when you see these labels, you see these at design time. The technicians don't see these at runtime, but these are actual bookmarks for these points. Okay, they identify these particular test points. And then the MPTE, which is multiple test point equation, it's going to use these three. So if we actually look at that, okay, here's our equation. It's going to be length, width, and height. And these are these variables, which will correspond to these bookmark names at design time, when you're designing the data sheet, will be essentially the nominal values for the test point. But at the time of measurement, when you're actually performing a measurement, if you're doing like your as left measurements, these would be the as found. Did I say as found? Let me say that again. When you're doing your as found values, these values will be the as found measurements for length, width, and height. Okay. And then this equation will determine the measured value for volume. Okay. And again, like I said, these actually all have their own uncertainty budgets. And so what's going to happen in here, when we select the test points that we want to add to the equation, it's going to automatically, using partial derivatives, calculate the sensitivity coefficients for that. All right. And then you also have the option to use correlation if you want to correlate those different uncertainty budgets. So if I click on this, so you can see here's our length, width, and height, our correlation matrix. And so if I click on this one, this is our width and our length. And what MPS will automatically do is it will set up this correlation analysis for you based on what the items are. And then you can override it. So this part is fixed. The one on the left is always the fixed one. It's going to have all of its budget items. And then you can, on the one on the right, it will give you basically the ones that you can adjust. So repeatability, obviously repeatability, but if for some weird reason it wasn't, you could tell it, no, that's really operator error or something. All right. So the only thing you have to do is set those and then provide the actual correlation values for the items. Okay. And if you don't want to go into like this level of detail, you can also, just like you see this one says M, okay, because you can just choose manual entry, right? And just enter correlation values if you just want to do that. Okay. You don't want to go to this, this length. All right. So there's that. Now, what happens is, so you've done all this uncertainty work and all that and all this uncertainty analysis. Let me just go to the advanced uncertainty editor here real quick. So in the data sheet, you can put in basically, who the analyst was for the uncertainty analysis and all of that stuff, right? When the analysis was done, all of that. You can also put in notes about the uncertainty analysis, again, using RTF. So you can cut and paste from Word. For each test point, you can put in comments if you want for that uncertainty comments. And what that all comes down to is ultimately you can also do this report. So this is going to be an uncertainty analysis report for this data sheet.
This is huge. I love this part.
If you click on this and you tell it to do all test points, then what happens is it's going to come up with this report.
This is why he says it's not a data sheet, it's test points right here.
Oh, yeah.
Yeah, it's really, the data sheet is just a collection of test points. Everything, from a metrology standpoint, what matters is the test points. Okay, so here again, this is the header information for the uncertainty analysis, including, like I said, you can put any comments you want. And this is actually giving you the document information about the data sheet. And, I say the term data sheet, but, the data sheet really is the template for the calibration. And with automation scripting, it can include, as I showed you with the automation, you can include the calibration instructions. You can make a data sheet an entire calibration procedure, all right? Okay, so, but anyhow, this is giving you all the document information, including those unique identifiers for the data sheet, all right? And basically who approved the data sheet and when into the database. And then for every test point in here, and let's get to one that actually has some. And again, like I said, this is I just have a lot of like nonsense stuff in here from me testing stuff. But this is actually a good one in spite of the budget items just being nonsense, it actually will illustrate guard banding. So it shows you again what the test point looks like. And then down here now, this is our uncertainty analysis for this test point. This is our uncertainty budget. We've got 2 items, standard 1 and standard 2, and there's basically your information about that, including the distributions and the standard uncertainty. If we were using degrees of freedom, the degrees of freedom would be in there. And then here's your combined uncertainty, our uncertainty confidence, effective degrees of freedom, coverage factor, expanded uncertainty, and here's my risk information for this test point. So here's the risk using the design tolerance. You can see my PFA is 1.3%, which exceeds my 0.8%. So we automatically are using guard banding, and it's telling us the method we're using is the Z540.3. In the case of MPS, that's going to be the RP18 statistical iterative process. And then basically our target PFA using that guard band multiplier is that, back to our 0.8% essentially, and so on and so forth. Now, when we go down, it's going to do that for every test point. But let me just jump down to the end here, because this is that volume test point. Okay, and that one looks a little different. So for the volume, that's the test point. And then telling us essentially what our equation inputs are, our length, width, and height test points, and all the information about our calculated sensitivity coefficients. And then the same information about the uncertainty budget there. And then our risk information. And then here's essentially our correlation matrix, right, that we did. And then one of the points we did manually, right? So there's no analysis for it, but the 2 that have analysis, these are the correlation analyses for those. Okay. And then now here comes the cool part. Let's say you get a finding or something from your auditor, right? You basically want to send this to them. This report is different than what you would normally do. This report is actually done in RTF. And the reason for that is you can copy this and you can just paste that into an email or paste it into Word.
Wow.
Right?
Okay.
Yeah.
Yeah.
So you
They
can
thought of
do that
everything.
Yeah.
That whole term built by metrologists for metrologists. You know, we've been through it. We know the annoyances of what you would want to do, so we have it there. You know.
Oh yeah.
Okay. So
Bring it
now
right to the
I'm just quickly here going to show you some of the analysis stuff that MPS does. So this is a data sheet for a 34401 digital multimeter. And here we're looking at the calibration history for this test point. Okay, so this is basically right now we don't have any particular filter set. So you're looking at the as found and as left. And let me just take off as left so we can just focus on as found, which is most important for this. And as I go to different test points, what you're seeing here is that this is time across the x-axis. So this on the leftmost will be the first calibration we ever did using this test point of that data sheet and the measured values all the way out to the latest, okay? And then the center line is the nominal value. The red line at the top is the high tolerance, and that's the low tolerance is the red line on the bottom. And so we can see essentially how we've done there. You can also go in now and you can filter this on just specific assets, right? So if I wanted to look at, say, just that asset, this is just the measurement history for one asset. And if I actually wanted to go in now and have it give me an analysis report, and I told it to include the test point data. So now just for this one particular asset in this date range, and what we would do is if we were really doing this for an asset, we would probably pick like a calibration period for this maybe. Well, actually, no, we would want all the history for this, right?
Yep.
Yeah, so you're going to get a summary at the beginning. This is for the entire data sheet. The premise here being if any one test point failed, that calibration is a failure. All right, so it's telling us there were 7 tests, 6 of them were in tolerance. Here's our observed reliability rate, and then our recommended calibration interval. It's currently 369 days, and it remains 369 days. And the reason for that is probably because we don't have enough data, right? Given our configuration settings for our reliability target and all of that. Okay, so then now here it.
Oh, this comes into play, obviously, right, Alex? If you think about it, I mean, he's going to get to it in a second when he's going to show you the all, but you know, for this interval analysis as a Cal lab, and you've got, you're doing risk analysis, you got, out of tolerance recalls you're doing. This here is going to make it to where you can actually set up and do a quick report on all your standards and get a true idea of what your calibration cycle should be for the actual asset itself, or even just down to the test point. If you have a limited, it'll let you know, hey, you know what, this particular test point really only has a life cycle of like 60 days, so you can see that, and you can actually do all of your standards at once. And that way you can have more confidence in what's going on for recall analysis and the tolerances that you find during DUT cals.
Right. That's
Right.
way better than it just having set rules, you know.
I mean, can you see,
Nothing will be
can
over
you,
a year, except for
yeah. I mean, think about the use cases of this, right? And I mean, the amount of time we spend trying to figure this kind of stuff out normally, right? In a
oh
lab,
yeah.
if you don't have the tools to be able to do that. And then of course, this coming down and it's obviously all the engineering tools, your reverse traces are again to the test point, not to the actual asset, which is really amazing. So like he was going to show you like being able to run, as he has here, the statistics miner, and I'll actually give it back to him so he can show you what's going on there. I
Yeah,
just
yeah.
can't help it because it's amazing.
And you reminded me, Rob, that this is probably a better way to demonstrate it anyhow, is to really start with this one so you can kind of see the big picture of what it's doing. So um, in the statistics miner, what it's going to do is this is a data mining application. So what I showed you in this report, right, for one make model, so let me actually close this and let's actually have it use no filter, right, and have it use all the data. And then so this is basically for all calibrations. Okay. So, and then it's going to show the summary, and then it's going to show the um, recommended intervals and all of that stuff for individual test points. But of course, you're not going to go and do that manually for every data sheet, right, in your
Right.
inventory. So what you're going to do is you're going to start with the statistics miner. And what the statistics miner does, and I'll just run this quickly just to show you something, what it looks like running. And what this is actually going to do is you've got 8,656 data sheets in this database. And what it's going to do is for every one of them, it's going to go and grab all of the calibration history for it, put it in memory, and then using all of the data as a whole, it's going to basically do all of the different analyses, the interval and reliability analysis that I showed you for the entire population as a whole, save those summary results. And then in memory, it's going to filter for each individual asset and then do the same analysis just using the data for individual assets. And then it will save in the database the summary and results for those assets. And it's doing it both for the data sheet level and the individual test points. And then the second one, the CMS interval analysis, this is your more conventional type of analysis where it's going to use all of the make models in your CMS system, right? And basically it will do the just based on pass or fail of the entire calibration. You'll get the interval analysis based on that. And then what you'll actually do, and I'm just going to go ahead and stop this, that data that's in the database, that summary data, we can do analysis reports. So if I come in here, I want to do delta cal interval summaries. So what I'm looking at here is I want it to give me a list of recommended interval changes. So by make model, or I can have it do it by reliability. So essentially a dogs and gems report. Okay. And one of the main differences between the MPS data and the CMS data are really two parts. One is MPS, it's process specific. So if you have different processes that you use for doing the calibration, they would be on different data sheets, right? Or if you had 180-day specs versus 100 basis 1 year specs, those would be on two different data sheets, right? So you can basically be looking at data for, specific processes, whereas the CMS one is just basically for the make model as a whole.
And then of course, as you say in MPS and CMS, everyone talks about that much because that is MOX and whole, right? It's
Yeah,
just the CMS is your limbs and the MPS is the part that processes the calibrations.
right. Okay, so yeah, essentially the CMS is the go, no go, right? The whole calibration passed or failed, and MPS gets more into more detail about the test
Wow.
points and all of that. Okay, so you can also tell it, in other words, don't show me unless I have at least 5 samples, and don't show it to me unless there's at least a 10-day recommended interval change. All right, or you can
Well,
say
that's cool.
30 days or whatever, just so you don't have to wade through a bunch of junk for, see a bunch of stuff that says no, you don't have to change anything.
Right.
Okay. But actually what I'm going to do is I'm going to tell it instead to do it by reliability. So this would be essentially dogs and gems. All right. And so now this report you can see, so for each data sheet, this Dwyer 300 GT photovoltaic gauge, right? The average interval is 343 days, 16 tests, only 4 of them have actually been in tolerance, right, of the 16 calibrations. So it's recommending changing the interval to 172 days. All right. And it's actually showing you your reliability. And that's how this one is basically done. And then you also have like your end of period confidence and all that stuff here. Um, so yeah. And then if we go, all the way to the end, farther down the report, it would be the gems, right? All the ones that are, the 100% or whatever. All right. So it's really this report. What I was showing you where you would go into MPS. Let me just close this. Close report. And by the way, you see me like keep looking left and right while I'm doing this. Is because of my other monitor here on my right side. I have other stuff that I keep dragging over to see. That's basically where you would come in and do this, right? You would go into MPS because something like the one where it's recommending the interval change to 172 days from 300 and something, right? Now I want to know why. Okay, so I could come in here to MPS and load that data sheet and have it gather the data. And now I can come in and look at the reliability on the individual test points. So I can see which test points are responsible for that. And maybe
How
it's a
would
case.
you, Alex? How do you think what would be a great use case for this
Oh, I
from your
mean,
experience?
definitely, when you're trying to recommend equipment to somebody, what's reliable, what isn't. It definitely for your standards. Being able to see, you know, which ones are performing as they should. And I know it's probably on the maker model level, but I mean, in some cases, it might just be a particular standard. You may have this one, uh, you know, 5520 that's never been out of tolerance, and you may have a 5520 that, fails every time it goes out for cow. So,
You know what? I'm going to say it again, but wait, there's more. Because one of the things that you can do with MetSpec, for instance, you're talking about just what you said about the calibrator and what
yeah,
it's used for. This is a 34401 DMM. What I can do in here is, let's say, for instance, if I find that it's this DC voltage, this range, say, fails a lot. Okay. So now I want to know, could I derate it? Well, in order for me to decide that, I need to kind of know what I use it for, right?
right.
So one of the things that you can do is that you can come in here and right click and you could tell it to show MPS usage.
Oh,
So if you
wow.
remember,
Look at
we
that,
actually
Alex.
assigned these ranges to test points of data sheets as calibration standards, right?
Right.
So now because I've done that, I can have it actually go and show me all the test points in the data sheets that actually use this as a standard. And it will include the TAR for that. So if I go through and look and everything's like 100 to 1 or better or something like that, I know that I'm probably safe derating it.
Gosh,
And
talk
and
about
that
how protecting it against the corrective action with all these tools, right?
Yes.
Having to go back and say, hey, this was out of tolerance and not and having the confidence when it comes back being out of tolerance from the vendor, knowing this is okay. Right away, this is okay.
and this is another
The time we take to do that. Kurt, the amount of time we spend as metrologists and quality and technical just to make that
Days.
determination can take
right.
days.
Well, this is another important thing about this too, it being so dynamic, the way the system is. if you did actually come into this MET spec, let's say this is the 34401, but let's say if it was the 5522 calibrator, okay, and we basically derated one of its ranges. When you do that in here, you can go in and basically say change this to like, 0.01 or something instead of 0.0045. Okay, that's how we're going to derate it. So you would add note, describing, hey, why we did that, et cetera, et cetera. But when you actually approve this now as a revision, when you load any MPS data sheets that's using this, it's automatically going to reflect that change because MPS recomputes everything dynamically. So when you reload the data sheets, it uses the specs to recompute the tolerance. It recalculates the standard accuracy using the specifications for the standard, right? So if you change the specifications for the standard, that will automatically, when a data sheet gets loaded into memory, it'll basically, all the computations will reflect that change of the standard.
What do you think about that?
Yeah, that's amazing. It's like if you were to manually calculate every single time.
Right.
Yeah.
That's,
And did you see how fast that report opened up when
Yeah.
I clicked the button?
Oh,
I was
yeah.
like, holy crap.
yeah.
Within a second, though.
Yeah.
Yeah.
Okay. So that's that. And I don't want to dwell on
My
it.
dog attacking me. I'm sorry.
That's all right.
I got a puppy.
Just a couple other quick things I wanted to show you, really about automation. We had talked about stuff. You saw an example with ATE, automated test equipment, right, where we're communicating with calibrators and stuff. But there's a
Yes.
lot of other uses for automation scripting. One of the things that you can do with automation scripting is actually create data sheets. Okay, so the automation scripting actually has the ability to create a template to build data sheets. So here's a case, let's say, for instance, with torque wrench. One thing about torque wrenches, we always do the same number of points, right? It's 5 points clockwise, 5 points counterclockwise, and it's always 20, 40, 60, 80, and 100% of range. So for this one, you notice these are all zeros, and the tolerances are all zeros when I start. When I run this, it's going to come
Oh,
up and
wow.
prompt me for the specs. So I can give it the unit of measure for my torque wrench, right? Pound feet.
Yep.
Let's say our full scale value is going to be 250, and our percent of full scale, no, let's do 1% of indicated value. Floor error, none, and yeah, we'll go with 2 decimal places.
You use those
It,
really accurate torque wrenches, man.
yeah, so basically, and it's just asking us if our counterclockwise spec is different, okay, and it defaults to what we entered for clockwise. All right, and then basically now our boilerplate, right, this is where we would change this to snap-on TQS 250, so on and so forth. And I'm just not going to do that for interest of time here. And most important, where the heck these specs came from, right? You always want to include that spec reference. So when somebody comes back 6 months later to review this, and they can see where you got the specs from. Okay, so here it is. There's our data sheet, and this one actually is automation scripted too. And you can see this is also showing sampling. I was telling you about sampling. When you
Yes.
have test points configured for sampling, the sampling section automatically shows up. So if I actually went to calibrate this now, and for that 51, so if I entered 49.9, 50.2, and 50.1. Okay, so there's you can see my points there, right? Okay. And then so my measured value is 50.07, which is the mean of that. And this is showing me the raw values. There's my standard deviation. Now, I don't have this set up with standards or an uncertainty budget yet. I skipped that part. But if I did, it would have put that in. It would have added this standard deviation as a type A uncertainty budget item.
Oh, wow.
Just for the measurement. You, of course, don't see
Yeah.
that at design time because there is no standard deviation at design time. But when you
Which means
actually,
the uncertainty calculation is being done correctly, which most labs aren't doing that, right? They're
No.
not taking that repeatability into account. It's not going into their budget. It is, so you're getting a true uncertainty analysis at time of calibration.
right. So that's basically one example. Here's another example using a pin gauge set. If you've calibrated pin gauge sets, these can be a real pain in the butt, right?
Yeah,
Because
especially writing that data sheet. I mean,
that's correct.
But wait, there's more.
That's right. So now when I run the automation scripting, it's asking me what I want to do here. So I want to build a data sheet. And then it's just giving me some information about what it's going to do. And then, by the way, this is all done with automation scripting in MPS. So this is just an ordinary data sheet, but with no real test points. We're going to actually create the test points. But do note that we only have these two, and there's no values or anything over here. So now it's asking us for the first pin size. It's asking us for the step size. Are you familiar with doing pin gauges, Alex?
Yes.
Okay, all right. So it's asking me for the last pin size and then the step size. So the individual, for anybody else that's going to view this later, these pin gauges, there will be like a set of, I don't know how many, there's like probably 100 or so of them in a pin set, and they're just different size pins that increment by a little bit each one. And I think you typically use them for like go, no go. This one fits in the hole, that one doesn't.
Yep.
And then our units of measure, inches, or we can choose millimeters, number of decimal places, a plus and minus tolerance, because they're typically asymmetric. And then again, this is just going to be our label for the step number and for the function tested. All right. So now when I do that, it's going to telling me that it's going to create a list of pins, and I can manually edit the list if I want. So if it's got like spares or something, I can add those, or if it's missing some, I can remove them. All right. And then, so now it's asking me how we're going to actually do the measurements, worst case analysis or mean. I'm going to go with worst case. And then do we want it to actually store? Because, with pin gauges, you make 3 measurements, one on each end and one in the middle. And then either the worst case or the mean are going to be the measured value, depending on, how you want to do it. And then it's asking me if we actually want to store those 3 measurements also, in addition to the, measured value. And yes, we do. Okay. So now you can see it's actually creating all of those test points,
Ain't that neat?
including
That is very
it added, you see like these are teal, because it actually added the script commands to all these test points to communicate with a SIP measuring machine to actually measure the length. So you can actually write automation scripting with automation scripting too.
Wow. And I know I work here and I'm saying wow, but I always learn something, just because I'm so new with this, and this is wow, that's cool.
So we need to do like on that, the late night infomercials, right? Ooh, ah.
Oh, yeah.
Right.
Yeah, that data sheet could have taken hours to write.
So
right.
So now, and then again, now it's asking for our boilerplate stuff. And again, I'm just gonna, not do that here. All right. And then so now what happens is I will tell you there's a big difference between the torque wrench one and this one. This is a lot more sophisticated, obviously, than the torque wrench one. The torque wrench one is very simple. Automation just has really a few commands. This one has a lot more commands because it does a lot more, including, writing the automation scripting for the test points and everything.
Can you just kind of show, like, just real quick before we end the podcast, because we're getting running close on time, but just the last part, maybe just show them a little bit of the automated scripting and how easy it is to create something like that.
Yeah, I will. I'm going to do 2 things real quick, and then I will do that.
Okay.
And we can always trim the podcast afterwards or something. Okay, so this one is basically a step gauge, okay, a Mitutoyo step gauge. That's actually, other software is used to calibrate the step gauge, but we want the data from that to wind up in MOX. Okay, so that system that does the calibration, it actually exports data as CSV. Okay, so here's all of our data for the various runs, and we do multiple sizes and multiple runs, and then we do parallelism tests. And in advance, we don't know how many runs there are going to be or how many length measurements there are going to be, but we do know it will always be the same number of measurements in each run, that kind of thing. So we can figure some of that out. So now what's going to happen is this, when I run this, it's going to read that file. It's going to prompt me, so load data file. Okay, and it's just a little bit of information about what's going on. And then now it's prompting me to point to that file. So this is the CSV file that I just showed you. And so now it's reading the information out of there and it's building all the test points for it. And then now it's telling me to open a calibration channel so it can record the measured values. Okay, and I'm just going to do 1 and 1 here in the interest of time. All right, so now I run it again. Tell it to apply the measured values. And now it's going through and put in all the measured values. So it built the data sheet and put in the measured values, and it figured out all the stuff, and it used the average of the different runs and all of that stuff for the measured values. And
Wow.
then including that file also contained the uncertainty information. So if we actually look at this, you can see it's pretty simple uncertainty information. They have basically just have one item, but basically it read that out of the file and created an uncertainty budget item for it too.
Wow.
So I've got my TER, EMU, and PFA and all that from it too.
So you just imported the data and it created the data sheet
Yeah, exactly. So the what the
from,
automation scripting, again, like I said, it's not just about ATE, right? It's about basically doing other stuff with automation scripting as well. Okay, last example, and I know we're running long, so I will make this one quick, but this is actually pretty cool to see because in a lot of labs, you have stuff that you have done in Excel. Okay, so
yes.
you've created a lot of data sheets. Maybe you have some very complex math and stuff in Excel, and you'd like to be able to reuse that without having to recreate it or something. Okay, or maybe you have something like flow where you're going to use MPS to grab readings from all the different sensors and stuff, pass those readings to your Excel spreadsheet that you have, and have it basically do all the calculations and then read back the measured value and apply it, something like that. So this example, I'm going to just run this, and this is just kind of a simple little example that's just going to show it basically communicating with Excel. So with MOX, you have basically, you can communicate with any COM server, including you can write your own COM servers to do extensions for MPS. So if you have something that you do a lot that basically MPS doesn't support natively, you can create your own module and put a COM wrapper on it and call it from MPS. Okay, so in this case, we're using Excel, and then it's prompting me for the spreadsheet. All right, so now it's actually loading the Excel application, and you have an option whether you want Excel to be visible or not. All right, so it loaded Excel. Now it's basically asking me whether or not I want to see Excel. And yes, I do, because obviously for the demo, you want to see what's going on with Excel. And what's going to happen is there are two variables in MPS, right? Just with these two values. And in each iteration, it's going to change these a little bit. And then it's going to send these values to Excel. Excel's going to do a bunch of calculations, and we're going to read 3 values back. So you're just going to see these values, and you're going to see the values that got back for this demo. So when I hit OK, and of course, Excel is probably going to pop up. Oh, there it is. Okay. So just down here where you can see it. Kind of get that out of the way. All right, so here you can also see that MPS is very fast with COM. Right, so here's basically you can see these values being iterated and they're being written here, and there's a whole bunch of calculations that are going on in here, including there's a couple of little charts that are being updated.
Oh, wow.
Right, so yeah, so again, you can do all kinds of stuff.
Jeez.
All right, halt the script. So that is MPS. Was there, did you think you said there was something we wanted to do after this, Rob, or were you just
Oh, and I
saying
just
wrap it up?
oh, it was the automated scripting that's showing actually
Oh,
the
yeah, what it
wizard
looks
part.
like.
Just
Sure,
kind of like how, because the reason I say that is because I've worked with other softwares out there, big ones, and it is not easy to write automation. And I feel like our wizard is pretty cool, and I'd like to kind of show that and just how easy it is to just write an automation
sure,
for
sure.
calibration.
Good. Yeah, thanks, Rob. That's a good call. Okay, so Now, automation, you actually edit in calibration mode, not design mode. And it may seem counterintuitive in the beginning, but you do that because you need to be able to have access to calibration channels and actually work with data and stuff to test your scripting. Okay, so automation, let's go to edit here. So our editing tools only show up when we're in edit mode. And then let me change this to use the small icons. All right, so now what happens is every test point essentially is a procedure, okay, that can have script commands. So for something simple like a pass-fail test point like this, we don't need to call anything else. There's one command that does this. So if I double click on this command, okay, it has essentially just one argument, and that's the criteria for the pass-fail. So it's essentially an instruction. All right, and as Rob said, there's command wizards to help you do these. So if I click on the command wizard, are instructions in here. So all of your different instruction objects that you have in here. So this is like for your DC volts, AC volts setup. You just pick it. And if you need to create a new one for this, you can just click on add and it brings up the instruction editor. Let me just click an existing one here just so you can see what one looks like that's already here. Yeah. So it's right here. So you can just edit the instructions. And like I said, you can set fonts and all that. It's a basic RTF editor. But honestly, what I like to do is I'll typically type them in Word and then just copy and paste. Because, Word has, some nice formatting tools and it's got a spell checker and all that stuff. All right. And so, yeah, so then you just pick it and that's it. And then what happens is we can actually single execute this command. Do I have a channel open? Yes, I do.
Oh, yeah.
Okay. So now if I actually just single execute that one command, this is what the command does when you run it. It's displaying the instruction, right? That's basically our criteria where you're describing the criteria, and then it has a pass and a fail button. So if I click fail, then the test point failed. Pretty simple for that. Now for all of our other sections where we're going to actually do instrument communications, at the start of them, you'll see there's the teal thing here, and then all of the test points are basically, this is considered what's called a step group, a test group, right? So this is DC voltage. And so all of these commands are a member of that group. So we have to start from here. And the reason we have to start from here is in the first one is usually where we're setting up the instruments, right? The TI and all of that. So if you look at our commands, you can pretty much tell just from reading what's going on here. Sys image instruction, right? We're going to display an instruction with images. So if I single execute that so you can see what that looks like, that's this one, right? We've got an instruction and we've got one or more images that are displayed. You can have multiple figures with tabs here. So your instruction, refer to figure 1, refer to figure 2, yada, yada, yada. All right. And then again, as Rob pointed out, these commands have wizards. You can see this one's a more complicated, right? Because there's images and stuff involved and you have some properties for those, but there's a wizard to help you set it up. This is where you can pick your instruction, just like we did for the pass fail, or, edit the instructions. And then for our images, we can view the image here. If you wanted to add another one, right, you can add another one. And basically, if you need to, add one that's not in here already, then you can do import and, just import an image into it and then add it. So now if I've got to give it a figure number 2. Okay, so now if I single execute that, I've got 2 figures. All right, and then, so the next thing it's going to do is it's going to call a sub procedure in this meter calibrator reusable. So in MOX, you have what are called reusable script units. They're called script unit files. And so what you can do is if you have ones like for these meter calibrators, all right, we have all of the scripting in it to basically to actually find out which calibrator is selected. So you remember if I showed you, you can have like multiple calibrators in there from the different metspec files. So we need to know which one is being used because it may affect the commands. And then we have functions in here like set the output for 2 parameters. So if we were on, for instance, a AC voltage test point, and let me just do that. So if we're on this AC voltage test point, the first thing we're going to do is we're going to have it go out and read information from the test point. And the information we're going to read is we want to get the value for the first parameter and the unit of measure symbol, and then the value and unit of measure symbol for the second parameter.
See, I like this because I don't have to write that out, right? You already have that command. I select the command and then I can select the next command. It's in the wizard where I mean, right, Alex, like when you're dealing with doing this kind of stuff, you actually have to understand how to write like some kind of coding, right? And that's kind of how I do
Yeah,
it.
you had to have, the commands, where they're using metcal. I mean, you're practically writing code to get it to do, what it needs to, and you're hard coding those test points in there too. So
What's
Yeah,
that mean?
so
What do you mean?
what
What do you mean
what's
hard
that?
coding? What do you mean
Well,
by
like
hard
if you do a
coding?
medcal, like with a medcal procedure, I mean, you're telling it these are the test points you're going to check. This is going off of your exact data sheet that you already have, correct?
that's
So
correct.
it's
Yeah, it's
reading.
actually reading the values from the
Yep.
test point. Yeah,
That's a
so it's
totally different. That's a game changer. Yeah.
yeah, it's because
Yes.
we're going to use that to actually build a command for the calibrators. Right. So essentially, if you look at what it's doing is it's taking these and putting them in variables. And by the way, there are wizards for these too, right? So if we actually go and you edit this, go to the wizard. And by the way, we could also just go directly to the wizard if we want. So these are the class we're doing, right? We want the test point nominal values, but we could actually get information about the calibration header, model manufacturer description, that kind of thing. The calibration measurement data, right? And stuff like um, the criteria type, it's a calculated test point, right? It's numeric. Um, the, the EMU, the actual formatted labels for the EMU test ratio. If we have taken environmentals with it, we could get the humidity and temperature values for the recorded measurements, the actual measurement type, the measurement tolerances, all that kind of stuff, the risk information for the
So
measurement.
the coding's you're saying the coding's already is behind each one of those already.
Yeah, right. It will just give you that value for the currently
Oh, that's
selected
nice.
test point and channel, right? And then, you can even get like test point information, specifications, right? Test point equipment specs. So if you wanted to get the specs, read the specs, you can do that. So on and so forth, right? I won't, be
What do
hammer
you think
on
about
that
that,
too much.
Alex?
Yeah. So the
Yeah, it's convenient.
So the idea of this really isn't designed to be like a general purpose programming language like, like C# or, Python or something like that, right? This is designed for metrology and it's mainly designed so that for doing simple stuff like for writing scripting for doing handheld multimeters, calibration technicians can learn to do this themselves, right? You don't have to be a programmer. Now, you can also do very sophisticated stuff with this, as you saw the example like with the pin gauges, right? That's
Yes.
pretty sophisticated. And then also like the one about where we're importing that CSV file and parsing all that out and figuring everything out about that. So you can do powerful stuff, but it's also basic. All right, so that's the idea. And so these script units, though, they're reusable. So if I were going to do another handheld DMM, I don't basically need to redo the commands for the calibrator again, right? I can just come
You
in
just
here,
copy paste
right?
them.
Yeah, come into my script units and just add the script unit in. And then those are already going to be in the data sheet. And then it's actually in the test points for the data sheet is where you'll actually call those commands. So you can see like for a test point here, we're in the AC volts, right? So it's basically part of the AC voltage group, test group, right? And it's child sequential, which means that you have to run the parent first and you can't start running from the children. In our pin gauge, it would just be child. So, because obviously you need to be able to start from any pin, right? You can't get
Right.
like, 100 pins. You can't say, no, you got to go back and start at the first pin. Though that's pitchforks and
Right.
torches territory there.
Yeah.
Right.
Okay, so anyhow, but in this case, we need that because we do all of our setup for these tests in the first one. All right, so anyhow, this one, again, it's just calling that meter calibrator set output two parameters. It's going to call that function in the script unit that reads the parametric data from the test point and configures that makes the calibrator output that. And then this manual measurement, do measurement, because this is a handheld DMM that we can't read, it's going to actually prompt. So I'll just give you an example here. If we go to that one, it's going to actually prompt the user. That one just has one procedure. And I'll actually just step through this so you can see what it's going to do. But it's going to go and it's going to read information from the test point about the nominal value, the tolerances, that kind of thing. And then it's going to display a prompt for the user to enter a measured value. So if I just single step through these, you can see it's reading those. And then we're copying instruction. We're going to now query the user to ask them for the measured value. But you can see what it did was where it went out and read from the test point what the test point nominal value was and the tolerances, because it's going to display that. So the technician has that handy here to see when they're entering the value.
It's actually really useful too, because I can't tell you in many calibrations where, you know, if you got a junior technician, they're just taking data, right? They're just putting it in there. And if they can see that, whoa, I've got 4 volts here. I need to be 2.6 to 2.7. Something's not right. A lot of times the technician will stop what they're doing and they'll recognize. I know also our system does one better too, and it'll actually flag you and say, whoa, this is, you can see the line go way out. But this is just one more way of, like, you know, if you're doing thread plugs or something like that, and you're dealing with constants, right? You can have that in here to say, hey, you're looking for numbers here and here before your constants are applied. So there's like little cool little stuff like that that I appreciate about how this is set up.
Right. If you're, and like with our pin gauge data sheet that it creates, what it does is it will do a prompt similar to this. But if you're doing it manually, then it will give you basically for the, you know, the one end, first end, middle, second end, right, to enter those values. And then, you know, compute the average from that. All right. So just put in our 2.7001. No, 01. It was a 0 too many, I think. All right. And then what it did was it put that in a variable. And then this next one is bar to measure. So it's going to take that variable and make that be the measured value. And there it is.
Oh, wow.
So this could have been, you know, all of our commands for communicating with equipment are under Visa. We use National Instruments Visa for that. So all of those commands are Visa something. You'll find that basically like this NS dot, these are all namespace commands, right? System commands, datasheet commands. So there's command types.
This process is a lot better than any automation building that I've seen. Just, I think I want to go back to it, the fact that you have the data sheet already. You're making a manual data sheet and using that information to create an automated data sheet, where I have not seen anyone, they'll, you know, they have to start all over from scratch, and they'll take that manual sheet and they'll look at it and say, oh, these are the test points we're trying to hit. And they'll write the script for those test points, where you could have any data sheet here and it's going to, and you have a wizard that's going to tell it, hey, this is the nominal value I need you to hit. This is the standard I need you to communicate to. And you're not having to do any kind of learning. You're just going through and selecting, so that way it knows to look at that test point and it knows these are tolerances and all that stuff. That is well, Alex, I mean, that's a unique way of going about it. You know, I mean, it's a game changer in the sense of saving you time and making anything available to you to automate.
Yes, and I just wanted to show you to emphasize another point about MPS. What's really kind of different about it than most systems is, again, it's really not about automation, believe it or not. This is a micrometer data sheet. We don't automate anything on a micrometer, right? We use a set of gauge blocks and optical flats. Now, let's say in the future, we decide that we do have some way that we're going to automate them, right? We're going to do some automated process. At any time, I can come in here to Automation Editor and just start adding automation scripting to this data sheet. Save it as a revision. And while I'm working on it, of course, as always, you know, you save it as a file, right? And then, but when we're ready to approve it, then we're going to come in here to approve template. And then this would be approve as a revision. And so now when you approve a data sheet as a revision, you can see here's the past versions of this data sheet, right? So now basically you can see that this one is active, but when we approve this as a revision, that one would no longer be active and the new one would be active. But here's the neat thing about MPS too, is let's say if something is just horribly wrong with this and we just want to roll back to the previous one, you can basically choose a previous one and reactivate it. Okay, so it'll inactivate this one. So you can say, you know what? You need to fix the automation scripting. You know, whatever you did, it just doesn't work, right? Something,
Oh, that's
we
nice.
just sent this thing out into the weeds, right?
Yeah,
Okay.
I've noticed a lot about that with MOX. Is it's really designed to be able to go backwards too, not
Yes.
just forwards. Not once you make it, you don't have to start all over again. Which, after talking to Alex for many years, we've dealt with that a lot. Where you make a mistake and shoot, I got to start all over
Yep.
again. And it's so frustrating.
And you can also, one of the most common reasons why you do see revisions in data sheets, one is automation scripting. It could be just like we said, right? It could be that there's something about you're going to support another standard that didn't exist before or something like that, or, you're going to change the technique or something. But even just ones that basically don't have any automation scripting, you might be revising those because somebody made a mistake on the specs, right? And you identify it. And so you're going to basically correct the specs and then approve it as a revision on a certain test point. So you also have here on this an audit report. So you can actually audit documents. So if you click on this, this will actually show you the audit trail history for this document. Who approved the revisions when. You'll notice there's always a pair. There's approval. The first one is just approval, but then on subsequent revisions, you're going to have approving the new one and inactivating the one that was approved.
Have you seen anything like this before, Alex? From
No, this is
dealing with
complete
any
audit
soft?
trail. No, I mean, I would say, I mean, just the audit trail itself is extremely useful. You can backtrack, you can see who made those changes. And, realistically, it's understanding why. Did you really mean to revise that data sheet, or hey, should have this just been a completely entirely new data sheet, written for a completely different standard? So,
Yeah.
Well, and
yeah.
what's important too about a MPS, it does treat these like documents. Okay, so a data sheet, a met spec sheet, a calibration, they are considered document entities. So when you save it, it saves the entire thing as a new revision of the document. So, and typically, we talked about examples where you've got a data sheet, two data sheets, one with 1 year specs and one with 180 day specs, let's say, and maybe even another one with 90-day specs if necessary. The way you would do that is you would take whichever one you create first, right? Let's say you do the 1 year specs. So you approve that, and then you just edit, right? You edit let's go back here real quick. So this one, if I were going to change it, I would just come back here to my test point builder, and then I can click on a test point like this one, and then you just click on TP and it reloads the test point builder with the
Mm.
specifications because it stores all the atomized components of the specifications in addition to the human readable friendly, right? So people can read it, but it actually needs this. So if this were entered for this would say the 1 year spec and the 90-day spec was 0.07, right? Okay, so I could basically go through and make those changes. And then what I would do is I would, come to my header, right, and change this to 90. And then I can find my mouse cursor again.
There it is.
There it is. And then now basically, when I'm done, I'm going to come in here to approve, but now I'm going to tell it to approve it as a new document, not a revision. This will issue it all new document identifiers. Every document has, see these globally unique IDs, these GUIDs?
Yes.
All the versions of this document have the same document ID, but every one of them has a different revision ID, a version ID.
Hmm.
So you can find documents, and this same thing applies for test points. Every test point also has a pair of these as well, its own pair. And this is what I was telling you about, like when we look at calibration history, how it can unambiguously match historic records to test points. It's because those measurements will contain these document IDs. So
I
I'll
see
know
the cat
not
in the
only,
background.
yeah,
Sorry.
there's
Squirrel.
basically keeping an eye on us. So what they'll do is it will make sure it will tell you not only which test point was used to make the measurement, but which version of it was used to make the measurement.
Oh,
So
wow.
you can associate that if you had a problem with this, maybe a specific version was wrong, and you needed to find all the calibrations that use that version, you can do that. Okay. All right. Well, I think that's pretty much everything I was going to show you, unless